we're gonna continue this lecture that we have started last time with the quadratic equations. So the second part of this lecture is a story about parabolas. The parabolas are curves that have this kind of equation, right? In general, they're gonna have some number of x squares, some number of x's, and then there will be some extra number that is a constant, like 5. So I would have here the number of x squared is 1, the number of x is -6, and then this constant number is 5 here. We will ask this number to be different than 0, because if this number is equal to 0, then I would have something I know really well about, or you're supposed to know really well about it. There will be an equation of a line with a slope b and with an intercept c, and that would not be what we will call quadratic equation. It doesn't have any square. Quadratic equation is to have a square. Okay, so this is the all requirements we're going to have, that this a, the number of x squared, must be not 0. So this is a format of a quadratic equation, okay? That is going to give you parabola. So why am I saying quadratic equation when you already learned the quadratic equation was this story? Quadratic equation that we just call quadratic equation in the previous lecture, or I mean the same lecture in the part 1 of this lecture. Well, this is a quadratic equation with one variable. The variable is an x. Now, if you add an extra variable, y, then you get a quadratic equation with two variables. And that's what we are going to talk about. So, quadratic equation with two variables. Just like we were talking about linear equations with one variable. There was something we were solving in the very beginning of the story when we were doing the equation story. And then we were talking about lines, which were with two variables, x and y, right? And then we also call a linear equation. The equation of a line is a linear equation, so with two variables. So this is the same thing here. So we have now two variables, x and y. This could get more complicated. We could also have a square of y, we could have a multiple of y, we could have an extra constant for, well, that would not make much of a change. We also could have an x and y multiply. Oh, that is a type of a quadratic equation with two variables that you can study in calculus. You're not going to be studying that in our course, so we're not going to talk about that. So this is the furthest we're going to go. Okay, when you have something like this, you might want to know how is this going to look like, because again, you have the points in the plane whose x and y will satisfy this equation, and those points are going to be somewhere in the plane. Are they going to make any kind of shape? They're certainly not going to make a shape of a line, because obviously this is not an equation of a line. It's going to be something else. Now, how is that going to look like? So, that's your question. Well, for one thing, when you don't know anything about the equation like that, you want to find out the intercept. So, the x-intercept is an easy one. Or is it? I don't know. Let's see. So what is an x-intercept? It has to have y equals 0, right? So if y is equal to 0, all of a sudden you discover you actually have quadratic equation with one variable. You need to find out what an x is. Now you can do it in lots of different ways. You can complete the square, you can do the quadratic formula. I'm not going to do either. And you can factor. That's what I'm going to do, because it's an easy thing to factor here. You need two numbers whose product is 5 and whose sum is -6. That's obviously -1 and -5. When you make a product of -1, -5, you get 5. When you make a sum of that, you get -6. So this is our simple story here, and you have two solutions. When this is equal to 0, zero product property. When this is equal to 0, the first solution is 1. When this is equal to 0, the second solution is 5. So you actually have two x-intercepts, 1 and 5. 1, 0 and 5, 0 for points, right? Now the y-intercept. Okay, what do we know about y-intercept? The y-intercept has to have the x equals 0. Now this is very easy to calculate here. X equals 0, x equals 0, y is equal 5. Really easy. Okay, so now I have 3 points. Now I can start graphing. Pardon my imprecise line here. Let's do it a little better. So you should probably use some kind of ruler, right? I do actually have one, but I'm kind of lazy to do it. So I have 3 points, 0, 5. One, 0. And 5, 0. Okay? Now, I am really not going to be able to guess what the shape this might take. Once you go, I want to find out what's happening here, because right in the middle of this. And then I want to know what's happening here when I go further. I kind of think that this is going to go down here, but then what else is going to happen? So I could do a little point plotting. And point plotting, of course, is the things you know well, I think, about the story of, in the story of lines we use that often. So what happens when x is equal to 3? That's an easy thing to calculate. 3 squared minus 6 times 3 is -9, plus 5 is -4. So I'm not writing that, I'm sure you can do it, it's an easy thing to do. 3 squared for an x, 9, 3 here, 6 times 3 is 18, 9 minus 18 is -9, you add 5 to that, you get -4. So I get -4 here at 3 for an x. Okay, so I'm kind of guessing that this might be going like that and then going up here. And now the next thing I want to know probably is one more strategic point to find out what happened here when x is equal to 6. Okay, when x is equal to 6 is 6 squared minus 6 times 6, which is 6 squared minus 6 squared, which is 0. You get 5. So that's the strategic point here. 6, 5. And now I think I have an idea what is going on here. This is what's happening here. Okay? Now, I have no reason to believe that there is any kind of curving here, so I think it's just going kind of sort of straight here. This cannot be broken. It has to be smooth. It has to be smooth, not broken. You might ask the question, how do I know that? Well, I'm going to leave that for calculus. You're going to learn that there. But in either case, it cannot be broken. It has to be smooth. So, now, the next question you might have is, how do I know this is not going to go lower here? Maybe it's coming here, and it goes a little lower, and then it goes back again. Well, that's a good question. Okay, I will learn that by completing a square here. And you might wonder, how do I complete square here? Well, I'm going to complete square with these two guys. Okay, so you have an x squared, you have negative 6x, half of this is 3, negative, and that you're going to square and add. That's going to give you 9. This is a complete square. This is a perfect square. Again, you have a square of x, you have a square of 3, and you have 2 times 3 times x here, 6x, with a negative. So you are talking about -3, really. Square of x, square of -3, 2 times x times -3. That's a complete square. But of course you have 5 here, not 9. And this ought to be equal. So you need to subtract 4. So you can see here, I did complete square here. These two guys, I got a third term. And to make it equal, I need to have this to be 5. Because it has to be the same as before. So now I have x minus 3 squared minus 4. Complete square minus 4. So you might wonder, why do I need this? Well, it's easy. The story is that this could never be anything less than 0. The smallest number you can get here is 0. Anything else, when x is something other than 3, when it's 3, you get 3 minus 3 squared, you get 0. If x is anything else, you're going to have some number here, when you square it, it's going to be bigger than 0. So the lowest you can get is 0. And that's happening when x is equal to 3. Right here. You will get a y the lowest. And what is that going to be when x is equal to 3? This is going to be 0. You're going to have negative 4. Negative 4 is the lowest you can get here. So I know now that you cannot go lower than this. This is the lowest point. At this point you have to turn and you have to start going up. You cannot go any lower. That's how I know it. So we're going to call this vertex. Turning point. You go all the way down to that, and then you have to go back up. Okay? I already know that this vertex has the coordinates 3, negative 4. Again, you can see it here. What makes 0 here? 3. When you have 0 here, what do you got? You got negative 4. That is on the parabola. What else you know here? You know that this and this are the intercepts, x-intercepts. And those are the solutions. You got them by solving quadratic equation. Which means that these two guys, 1 and 5, are x1 and x2 out of this equation. I didn't get that from the quadratic formula. I got them by using factorization. I factorized rather than use the quadratic formula. But you can use a quadratic formula. If you use a quadratic formula, the x1 is going to be negative b plus minus b squared minus 4ac. That is the meaning of quadratic formula. x1 is for plus, and then x2 is for minus, right? Now I'm not going to do that. I'm going to leave that to you. This is your exercise. But if you do that nicely, this first one will turn out to be 5. And this second one will turn out to be, guess what? 1. 1, 5. You check it out. You have here in this story, A is equal 1, B is equal negative 6, and C is equal 5. One, negative 6, 5. Okay? Plug it in here. I guarantee you're gonna get 5 out of this. Plug it in here. I guarantee you're gonna get 1. It has to be. Because when you solve the quadratic equation by using the quadratic formula or solve it by factorization, you will get the same solution. Okay? But what I want to point this out is that this guy here is the average of these two guys. 3 is the average of 1 and 5. It's right there in the middle. So it has to be the average. If you have 2 points on the real number line, the points in the middle between those 2 points is going to be exactly the average of those 2 numbers. That's the very simple story. So what's the average of these 2 numbers? I already know in this particular case it's 3, but in general, Well, you get b plus something, you get b minus something, actually negative b plus something, negative b minus something. You can also split this. So you write like that. B over 2a minus the whole radical over 2a. You can do the same thing here. B over 2a, negative b over 2a, plus the whole radical over 2a. So you having this number and add something, and having the same number and subtract something. Like 30. You add something, 5, you get 35. You subtract the same number, 30 minus 5 is 25. What's the average of 25 and 35? 30. So this is the average of these two guys. In other words, the x of the vertex has a formula. It's negative b over 2a. You can work this 3 out that way. So in our case, there would be negative 6. That's a b over 2a is 2 times 1 because a is 1. 1 negative 6 5. And this is, of course, 3. Positive 6 divided with 2. Okay, what's the y of the vertex? I don't know. In this particular case, it's negative 4. But in general, what is it? So in general, you have this. Okay? You're gonna have a y of the vertex if you plug in the x of the vertex into this equation. So in our particular case, we had 1 times x squared minus 6x plus 5. The x of the vertex will give you the y of the vertex. When you plug the x of the vertex here, it will give you the y of the vertex. In this story, the x of the vertex is 3. So you have a 3 squared minus 6 times 3 plus 5. And that, of course, is negative 4. So you really don't need a formula here. The only thing you need to know is what is the x of the vertex. Once you know the x of the vertex, you just plug in the x of the vertex in the whole equation, and you end up with the y of the vertex. So if you plug in 3 here, which is the x of the vertex, you end up with negative 4, which is the y of the vertex. Because they have to make this equation true, because the vertex is on the parabola. It's going to satisfy the equation, which is in our particular case, you have this equation. That's the equation of the parabola, our particular parabola, this one here. Every point here on this parabola has an x and a y, and they all have to satisfy this equation. So that's the vertex. Vertex has an x and a y, has to satisfy this equation. So which means that this must be true. So if you don't know what the y of the vertex is, and you know what an x of the vertex is, you plug it in here, and you calculate the y of the vertex. I just found out that was negative 4, because I knew the x of the vertex is 3. But in general case, I can make a formula. So what is going to be formula? I'm going to have to squeeze this a little bit. Okay? You will plug in the x of the vertex, which is negative b over 2a. That's the x here. You have x on one more place. And then you have a c. Okay? And now you have a little more algebra here than you want. Okay, but I can work it out. So this piece here is a cancels a. I have another a here because I need to square this. So I get the b squared over 4a. squared. A and A get cancelled, we have B squared over 4A. I'm going to leave that to you to do it on scrap paper. Minus is gone because we're going to square it. I'm going to have to square it, so I have negative times negative, which is positive. So I have B squared over 4A. You check it out. Square it, multiply with A, cancel one A and another A. Now this one is much easier. I just have a negative B squared over 2A plus C. Okay? This first part is easy. This thing here is a half of this thing here. When you want to make a half of a fraction, you just multiply the denominator with 2. So it's exactly what you have here. So when you have this added or subtracted, you're gonna get negative this guy. By the way, you can check it out by multiplying up and down with 2. That's how you get the common denominator, and now you subtract. This guy minus this guy is this guy minus this guy. So you get negative B squared over 4A. And then you still have a C. And I have one more step to do. You can leave it this way, so you have already a formula for the y of the vertex, which is C minus B squared over 4A. That's perfectly good, right? I just reverse this because I want to put the positive forward and the negative backward. That's it. If you don't like to have this as two terms, you want to have one term, you're going to have to have a common denominator, it's going to be 4AC. This is easy to remember, minus B squared over 4A, whichever you prefer, one or the other. So this is a formula for the y of the vertex. Okay? It's going to work in this particular case. Let me check it out. So I do have the y of the vertex in the case when the equation is 1x squared negative 6x plus 5. That's the story about this parabola. So this shape is called parabola, right? Parabola is a Greek name for a curve of this particular shape. It's known already for hundreds and hundreds of years. So we have, this is not a new thing. We know about parabola. They're very important. They're important in physics. And in astronomy. Well, it's sort of a part of physics, right? So they're important. But we're not going to go into physics about it. We're going to study it in a pre-calculus, and if you get to pre-calculus, you're going to learn more about it. But I want to verify this formula. Which one I'm going to use? This one or this one? They're the same thing. Maybe this one here. So if I want to use a 4AC, so here is A is 1, B is negative 6, and C is 5. A, B, C. Plug it in. So I'm going to use like the second formula, right? Either one of them. This one here, 4AC minus B squared over 4A. A is 1, B is 5, C is B is negative 6, excuse me. And C is 5. I'm plugging in 1, 2, 3 into this formula. This is not too hard to calculate, it's just a question about your work. You got 36, 20 minus 36 is negative 16, divided with 4 is negative 4. And that's exactly what we have down there. Notice I actually got that by completing a square. I wasn't really working this formula. So this is not a formula to remember. Who cares? If you want to write the formula for a vertex and that you want to have an x and a y, is going to have negative b over 2a. You're going to have to remember that. That's, by the way, really not that hard. And the second part is this piece here, 4ac minus b squared over 4a. But again, you really don't need to remember this. You just need to remember this, because once you find the x of the vertex, you just plug in the equation. 3 is the x of the vertex, 3, 3, and you get this negative 4, which is much easier than try to remember this formula. The first part you do need to remember that, but it's really not that hard, because it's from quadratic formula. You have negative b plus minus some radical here, and then down there you have 2a. So if you can remember quadratic formula, here it is. The first part without radical. So that's this guy here, right? So that's our first example of a parabola. Let's get one more, or a few more. So I'm going to use example number 8 or 9 in the lecture, which is on the blackboard. I'm going to use the example, let's see, 9, and in there I have x squared minus 2x minus 3. So y is x squared minus 2x minus 3. So I have a is equal 1, b is equal negative 2, and c is equal 3. Okay? I can immediately find the vertex because I have a formula for a vertex. So again, I will have to find the intercept as well, of course. I need, so there might be more than one x-intercept. There's only going to be one y-intercept, and that's easy. The y-intercept will be when x is equal 0. When x is equal 0, you get negative 3, so that's easy. 0 for an x, negative 3 for a y. Again, the y-intercept must have an x equals 0. And you plug in x equals 0, you just get this number here. And that's y equal negative 3, so that's an easy part. The x-intercept, so the y-intercept, right? The x-intercept is a little harder, so you need to solve the equation here. So you can do x1, 2, and the quadratic formula and so on. You don't need that here. You just get this by factorizing, which is a very easy thing to do. Right? Factorization is quite clear. I mean, you have to multiply two numbers to get negative 3, and to add those two numbers, you need to get negative 2. So this is exactly what you have, negative 3 and 1. And therefore, you have two x-intercept. One of them is when x is equal to 3, and y must be 0. For the x-intercept, y must be 0, the x is something. And the other one is when this is equal to 0. So I'm using here 0 property. This is equal to 0 when x is equal to negative 1. Negative 1 and 0. That's the second x-intercept. Now I need a vertex. I have the formula for the vertex. Negative b over 2a. And then I have some long formula here, which I don't remember, right? I wrote it down, but I don't remember it anymore. You don't need to. This piece is easy. So I have the x of the vertex, negative b over 2a, which is in my case negative 2 and 1. And the story here is that I'm getting 1 here. Now I have to multiply this, and we're going to get positive 2, and then divide with 2, which is 1. So this thing here is 1. Too much space here. And what's the second coordinate? You remember this. Oh, I just wrote it here, x of the vertex. The y of the vertex is equal the x of the vertex and the rest of that is just equation. So I got the, all right, 1 minus 2 is negative 1, minus 3 is negative 4. Done, right? So you don't need the formula here. Again, the value of the vertex you can get by the formula, or you can just simply find the x of the vertex and plug it in the equation, because the vertex must be on the parabola. So now you have 3 points. Oh, 4. X-intercept, 1, 2, y-intercept, and the vertex. You can start graphing. And you might need to do a little more point plotting to find out where that parabola is. So I have 3, 0. I have negative 1, 0. I have 0, negative 3. And I have 1, negative 4. Okay? I have a pretty good idea what that's going to be. So I might want just to find out what x equal 2 is going to give me, because I'm kind of thinking this is going to happen, but let's see what it does at 2. So you got 2 here. Calculation is y is equal 2 squared minus 2 times 2 minus 3. So we're talking about 4 minus 4 minus 3 is minus 3. So exactly what I expected. So this is my parabola. There you go. It's not particularly nice. I should probably make it more symmetric here. I went too far away from this point. So let's recover this a little bit. Maybe like that. Okay, and I have to have a smooth end, not broken end, not broken, but smooth, right? And again, the reason for that you will find out in calculus. So one more time, I was doing the intercepts, I was doing the x-intercept, y-intercept, the vertex, and one extra point to get the strategic idea what that is going to look like. You can already figure out some features here. If you keep on increasing x here, so x is big number, this doesn't matter. Let's say this number is 100. If x is 100, you get 100 squared, which is 10,000. And this is, 2 times 100 is 200. 10,000 versus 200. 10,000 is a much bigger number. So this guy tells you more about what happens when you go that way. You're going up. When you go that way, you're also going up, because it doesn't matter whether it's positive or negative for an x. When you square it, it's going to be positive. So it must do this, that way and that way. Okay? So the question is, what if I put negative here? Because in that case, it's going to go down. You're going to have a big negative number, right? So the y is going to go down. So let's do that. One more example. With the negative start, like negative x squared plus 2x plus 1. Okay, the same story. I need a vertex. I might want to have a strategic point down the road. I need to have the y-intercept. I need to have the x-intercept. The y-intercept is easy. So for the y-intercept, the x must be 0. When you plug x equals 0, 0, you get 1. So that's the 1 point immediately. For the x-intercept, you need to solve this equation. Oh, we never had any equation, quadratic equation has a 0 to start with. Well, that's easy. You multiply everything with negative 1, so you're going to have positive to start with. I multiply everything with negative 1, just to have a x squared to start with. Now you have the factorization. You have x minus 1, x minus 1. Oh, one of them must be positive, excuse me. So I need two numbers. One of the number has to be negative, one of them has to be positive, and when I add them, I need to get negative 2. Alright, no factorization, this is a prime. Alright, too bad. Well, we're gonna do the good old story. Quadratic formula. Minus b plus minus b squared minus 4ac over 2a. Okay, so again, I was trying to factor this, but I realized I don't really have a factorization, so I can't factor it. This is actually a prime. It's really hard to see that. It looks like it might not be, but it is a prime. So I need to do the either completing a square or quadratic formula, right? So quadratic formula here, 1 for an A, negative 2 for a B, negative 1 for a C. I'm going to do it both ways, but I'm going to do first quadratic formula. Quadratic formula here is actually harder than completing a square. It's easier to complete a square. So you have A here is 1, B here is negative 2, and C here is negative 1. Okay? You plug negative 2 for a B, plus minus B squared minus 4A C divided by 2A. Not an easy thing to do. Well, it's not really that hard to do. It's just a question of so many places you can make a mistake with sign easily. So you go 2 plus minus you get 4 here, and you get another 4 here, so this is 8. I made too much of a space here for an 8. So again, 4, negative 4, negative 1, positive 4, this one plays no role, so you get 8. 2 downstairs. Okay, 8. Scrap paper. I'm just doing scrap paper here. 8 is 4 times 2, 2 radical 2. Radical of 8 is 2 radical 2. So you have 2 factors, 4 times 2, that's 8. Radical of the 4 is 2, radical of 2 stays 2. So you got 2 plus minus 2 radical 2 over 2. Well, such a fancy stuff, right? 2, 2, 2, 2 everywhere. Anyway, common factor 2 cancel out. You get 1 plus or minus radical 2. Well, that's our intercept. The first one is 1 plus radical 2, 0. The second one is 1 minus radical 2, 0. You will probably need some approximation here, because when you start graphing you will need an approximation. So those are the intercepts. This one here is approximately 1.41. When you add 1, it's approximately 2.41. This one here is negative 0.41. Okay? So I had to do that. You could have done this by completing a square. X squared minus 2x plus 1 minus 2. Okay? 1 minus 2 is minus 1. And this stays out of here. This here is a complete square. What squared? X minus 1 squared. And this 2 on the other side is right here. And now you can have again the x minus 1 squared is equal to x minus 1 is equal radical 2. It could be plus or minus. And now you have the same thing. X is equal 1 plus or minus radical 2. You have two solutions here, x1, 2. 1, 2. Okay, so this is by completing the square. Your choice. You can use the quadratic formula, which I just did, and you will find those intercepts. Okay, done. The next thing is vertex. The vertex has the x of the vertex, and I hope you'll remember the formula we already had twice. So again, you have, I shouldn't have erased this, a is equal 1, b is equal 2, a is actually negative 1, negative 1. And c is equal 1, but I don't need it in this formula, I don't need it. So I have negative b, 2 times negative 1 for an a, and well, I get 1 again. So the x of the vertex is 1. It's negative 2 divided with negative 2. So the x of vertex is 1. The y of the vertex will have this fitting for x being the x of the vertex, and I already know that's 1. And now you have negative 1, 2, and 1. Negative 1 and 1 is 0, you got 2. So again, you don't need the formula y of the vertex. Once you find the x of the vertex, you just plug the x of the vertex right here to get the y of the vertex, because they have to be on a parabola. The vertex has to be on a parabola. So the x of the vertex and y of the vertex must fit this equation. So I have here x of the vertex and y of the vertex must be the same thing as the right side here, because you're going to have to make equation through. So we got that, and now we can start graphing. We might need an extra point. So I have 1, 2, 3, 4. Okay. The y-intercept 0, 1. The vertex 1, 2. Strange stuff. So this goes up here apparently. Okay. The x-intercept 2.41 approximately 0. So you're gonna have to do the graphing with approximations. 2.41 is like here, and 0 for y. This one here is approximately negative 0.41, 0. So this is negative 1, negative 0.41 is like here. It's a little less than 1/2, right? 0.41. So the next question would be the question of what is this parabola doing at 2? So one extra strategic point is when x is equal to 2. I want to know what the y is. 2 squared is 4, negative 4. 2 times 2 is 4. Negative 4 and 4 is 0, plus 1. I'm getting 1. 2, 1, right here. So this is what it is. Oh, this parabola is upside down. This one is a hat, not a cup. Okay? You gotta remember that. Whenever this is negative, you're gonna have that situation. The parabola is gonna go down. When you start with positive, parabola is gonna go up. Again, the reason is very simple. When you are taking a really big x here, like 100, this is gonna turn out to be a big negative number. So which means this stuff won't matter, which means that y is going to have a value of a big negative number. So when x goes that way, you're going down. The y is going to negative territory. Okay? The same thing happened on this side, because it doesn't really matter if you have a negative number here for an x. You're still going to square it, you're going to get positive, and this guy is going to make it negative. So again, you're going to go down that way too. So that's the story. So if you start with a negative, you are going to have a hat for a parabola. If you start with a positive, you are going to have a cup for a parabola. That's easy to remember. So this is not a surprise. Okay? Let's do one more. This example is in the lecture example number 10. The next one I'm doing is example number 10. So I want you to read the lecture, and if I'm too fast in some calculation here, you check the lecture and make sure you get everything right. So what's our strategy in graphing? We need the intercepts, we need the vertex, and if that's not enough, we also need the couple of extra points, maybe one. So I have here negative 2x squared, positive 4x, and positive 2. Okay? All right. The y-intercept, so that's peanuts, right? The x equals 0, 0, 0, 2. You get 2. Right? Plug 0 for an x, and you end up with 2 for y. So I have y-intercept. The x-intercept, I'm going to have to solve this. Okay? I don't expect this stuff to come up with anything nice, but I actually have something very simple here. I actually have the same thing I had moments ago. The same thing. When you divide with 2, you get 0. If you divide everything with 2. And you get negative x squared plus 2x plus 1. And this is pretty much the same thing I got moments ago. Alright? So, you check it out. Use the quadratic formula to solve this, which is x1, 2, negative b plus minus radical b squared minus 4ac divided with the 2a, right? This is quadratic formula. And you know what? You're going to end up with x1, 2 being 1 plus radical 2 and 1 minus radical 2. So, I guarantee it. But I'm going to leave it to you to work it out. I can also write it here like a plus minus, right? As long as you understand you have two numbers, right? But when you write intercept, you're going to write two intercepts here. So you're going to have the 1 plus radical 2, 0, 1 minus radical 2, 0. Because those are points now. So they have to have an x and the y. Y is 0, right? So I got that, and I can graph. Oh, I don't have a vertex yet. All right. We'll do that. So the vertex is, the first part is negative b over 2a. Okay? What do we have here? You have a equal negative 2 and b equal 4. So this stuff turns out to be negative 4 over 2 times 2 negative. You have to divide 4 with 4, which is 1. And you have negative here, it's going to be positive 1. And once you have the vertex, x of the vertex, the y of the vertex is just simply the equation. The y of the vertex is negative 2 times the x of the vertex plus 4 times the x of the vertex plus 2, and the x of the vertex is 2. Oh, 1, excuse me. I'm already misreading this. 1. So I have here negative 2, positive 4, that makes it 2, and 2. 2 and 2 is 4. Okay? So that is done now. And now I have plenty of points. Well, 1, 2, 3, 4, 0, 2. Good. 1, 4. Vertex. Here. This guy, 2.41 approximately. 2, 3, 2.5 is here, 2.41 is a little bit before. Okay, this guy here, negative 0.41, 0. Negative 1, negative half, negative 0.5, negative 0.41 is like here. You won't want to get what's going on here. So x, y, when x is equal to, what happens? 2 times negative 2 times 2 squared plus 4 times 2 plus 2. I'm doing this calculation when x is equal to, right? So you got 8 here, you got 2, that's 10. So this piece is 10. What do we have here? We have 4 times negative 2 is negative 8. So you get 10 minus 8. Not a surprise. So I'm giving a point here. Look what happens. I already know that this implies hat shape going downward. This is the tallest place. The maximum y. The maximum y is 4. You can never get any y bigger than 4. This is the point on a parabola has the maximum y. Every other point has a smaller y. This is going to play a role in pre-calculus. You're going to learn what a maximum and minimum are. Okay, what else I could notice here? I could notice here this story. Slope. Well, it's not a slope of a line, but it's something to do with the slope. This guy plays that role. If you move one to the right or one to the left, you've been moving 2 down. This guy tells you that. Right? Very interesting. So again, in this place, the x is equal to 1. If you move 1 to the right, you get 2. Or you move 1 to the left, you get 0. You will be moving 2 down. We already know you have to move down from the vertex. Both on this side, on the left side, and on the right side. You need to move down. But this guy tells you exactly how much. You're going to move 2 down. That's actually a slope for a parabola in the vertex. With respect to the point. So this point here and this point here. We were always calculating slope with respect to 2 points. You have to select 2 points and you're going to find out. So it's a variable slope. I shouldn't be saying it's a slope of parabola, because parabola doesn't really have a slope. It has every 2 points is a different slope. But if you move 1 to the right, and the next point on the parabola, and the first point you start with, which is a vertex, these 2 points will have the slope in between them, exactly what this guy tells you. And behavior is going to be the same on this side. Only, of course, you're going to be, from this point to this point, you're going up. So you have to look at that. How about if I go to the left? Then you're going down. And you're going down exactly how much this number is. Okay? This is an important observation for a parabola. Now, explaining that, I'm going to leave that for pre-calculus. In the pre-calculus, you're going to learn something about transformations of the curves, and then you're going to learn this explanation a little better. At this point, I'm going to just leave it a little bit murky here in dark. Y is exactly going this much. So when you move from the vertex, you're going that way, you're going exactly 2 down, down. When you move to the right, again, you're going to be moving down, exactly 2 again, right? So this will become clear in pre-calculus. In the pre-calculus, you're going to have this really nice explanation why this happens, okay? So, if you can remember this kind of stuff, then you won't really need any intercepts, actually. Let me show you another example when is not needed to have any intercepts. And you can still graph the parabola. So one more example, then we're done. So in this particular story, I'm just going to use this full information without actually doing any intercepts. But I'm going to use the vertex. The vertex is needed. So I have 2x squared minus 4x. Okay, I'm going to add 1 to that. This is an example number 11, but I changed this a little bit. In that example, I have 2x squared minus 4x and nothing else. So I just add 1 just for fun. Okay, so I don't need the intercepts. Again, you should be able to do the intercepts, of course. You should know how to find the intercepts. And let's say I'm in a situation where I need to get this parabola really quick. I don't have a time for intercepts calculation. I just want to do that as a sketch. So I just need to know quickly what that is. All right. So you do need to have a vertex, because if you don't have a vertex, you don't know whether, you know, to start making this shape or this shape. You don't have no idea where the vertex is. So you need to have a vertex. Vertex cannot be avoided. And the vertex is going to have the negative b over 2a. You got to remember that. Again, this is the first part of quadratic formula. If you raise the radical there in quadratic formula, you get exactly that. So you need to be able to find it. In this particular case, you have a equal 2, b is equal negative 4, and c is equal 1, but you don't need it. So in this calculation here, negative 4 divided with 2a, very easy one. I have 1. That's the x of the vertex, 1. The y of the vertex has to satisfy this equation with the x of the vertex being in place of x here. So you have y of the vertex is 2 times 1 squared minus 4 times 1 plus 1. 2 minus 4 plus 1, negative 1. Right? 2 minus 4 is negative 2 plus 1 is negative 1. So we get the y of the vertex. So vertex is at 1, negative 1. 1, negative 1. Okay? Now, this is a sort of a slope of parabola. If you move 1 to the right, you're going 2 up. If you move 1 to the left, you're moving 2 up. So you have 2 extra points, and one of them is coincidentally the y-intercept. Just happened. Okay? Here's your parabola. Right? This is just a sketch of my parabola. I'm not going any further. I don't need any more points. I have an idea of what's going to happen. So this is a vertex. This parabola has a cup shape because it starts with a positive number here. Cup shape. And I also know from this story about the slope, when I move 1 to the right, I need to move 2 up. When I move 1 to the left, I need to move 2 up. That's the numbers telling me. Okay? You can kind of guess where the y-intercept, x-intercepts are. Just for fun, I'm going to find them. So I'm going to find the x-intercepts. I have 2 of them. One is here, one is here. I did not find them I was graphing this as a sketch, and I get an approximate what it is. This seems to be somewhere between 0 and half. This sums to this is 2 here. This ought to be somewhere between 1.5 and 2. I don't know what it is, so let's find it out. Okay, so how do you find the intercepts? The intercepts you find, the x-intercept you find by making a y equals 0. So if y is equal 0, you get the quadratic equation 2x squared minus 4x plus 1. I bet this one is not factorizable, so I'm not going to even attempt to do that. You can try to spend some time to figure out whether you have factorization. I bet this one is prime, so I'm not going to try to do that. What I'm going to try to do immediately is quadratic formula. Or you can do completing a square, right? Assuming you know how to do that. So I'm going to do the quadratic formula because that's an easy one. Minus b plus minus. So I have now c here being 1. Radical b squared minus 4ac over 2 times a. A goes on 2 places. It goes here and it goes here, and it's 2. The b negative 4 goes on 2 places. One of them is here and another one is here. Oh, I forgot square here, right? In quadratic form we have that b squared minus 4ac. And c, which is 1, goes in one place only, here. So now, work it out. I get 4 plus minus. Let's see. 16, right? 4 times 2 times 1 is 8. Negative divided with 4. So you get 4 plus minus. I got radical 8 here, and I already did that today. So this is radical 8 is 2 radical 2. So I have 4 plus minus 2 radical 2 divided with 4. Obviously I would not be able to factor. Now I realize this one is prime. This is not going to come out of the factorization for sure. So this one cannot be factored. But let's do a little more work. So this is 1, 4 divided with 4, and 1/2 here, plus minus 1/2 of a radical 2, which we can just simply write as a half of radical 2. Radical 2, half. Okay? So, you need an approximation. This is approximately 1.71. Maybe a little less than that. 1.7 something. 1.71. Try to use a calculator. That's exactly what it looks like. 1.71. Yeah. Okay. So these are the x-intercept. Of course, the y is equal to 0, right? The other one is here. So that will be for negative. This will be 0.29. Approximately. Use a calculator. Approximately 0.29. 0.29. Looks like that. This is a half here, 0.29. It's a little more than a quarter. Yeah, my picture just fits. Okay, so this is the finding out the intercept. So the intercept, the x-intercept would be the first one, the second one, and of course y-intercept I'm not gonna bother, it's already here, right there. So it's when x equals 0, y is equal 1, 0, 1. So this is looking perfect. Okay, my story is done. You have one more example in the lecture that I didn't do. It's actually exercise for you. Example 11b. You might want to do that yourself to see what that's going to look like. Lots of stuff about parabola is also done by completing a square. You're going to discover more of that in the pre-calculus. we're gonna learn something about the transformations of parabola, so which is the easiest way to graph parabola rather than this stuff I was doing here in this lecture. But this is the end of the story we have for parabola and the end of the story we have for the quadratic equations. So quadratic equations. Quadratic equations with one variable when only x is in the game is a quadratic equation that we were solving in the first part of the lecture. Quadratic equations with two variables once you have the y in the game also. So again, you can have the square of the variable, you can have the multiple of the variable, you can have the constant, and also y. You could also have y squared in the game and x times y, so that complicates everything. Those are some other curves that we're not going into. But this simple format here of quadratic equation with two variables is an equation of a parabola. It has this kind of shape. It could go actually downward too, depending whether this number is positive or negative. Positive upward, open upward, negative open downward. The very important thing for graphing parabola is to find out the vertex. And then this number, left and right from the vertex, 1 unit is going to go exactly this much. Up if it's positive, positive 2, up 2, or down if it's negative. And there's more to it to this story, of course. And again, I already said this is you're gonna discover this in pre-calculus, and then something about the smoothness of the whole thing and the symmetries. You're gonna discover that thing in the calculus. Another thing I think I forgot to say that is that there is some symmetry here. And again, I'm gonna leave that to the story about pre-calculus. Symmetry is exactly where the x is of the vertex, which is in our case 1, but in general it's negative b over 2a. You know what this is? An equation of a vertical line. This is an equation of a vertical line in general case. So this line x equal 1 is what we call symmetral or symmetral of this parabola. If you flip the parabola around this line, it's the same. Every parabola has symmetral. And the equation of a symmetral of the parabola, it's a vertical line, is x equals something, and that something is exactly what the x of the vertex is. X equal 1. Right? Now, why is that symmetry? Well, you're going to study that in pre-calculus. So I'm making a big advertisement here for calculus and pre-calculus. Yes, because that's when you're going to learn a lot more about those kind of curves. You're going to learn a lot more about the curves that could have a lot more than y here, like a y squared and stuff like that. And that's what you're going to learn in calculus, though. So in calculus, you're going to have to study the calculus 3 for this kind of stuff. Actually, in calculus 2, you'll learn something about it too. And the pre-calculus, you're going to learn a lot more about graphing parabolas by doing what we call transformations, which is the easiest way to do that. And the many other curves we graph that way, but that's the topic we don't have in our algebra course. So this is the end of the story on quadratic equations and the end of the story on the whole course we have. And the last lecture we have. So what follows now is exam test number 4 online and the final exam online. That's all next week. So this is the end of the lecturing. Obviously you can find the lecture written on the blackboard, so you need to do the you need to study the lectures if you have time. You need to do the homework, which is a large homework on the quadratic equation number 18. It's labeled as an extra credit homework, but it's not an extra credit topic. So the homework is basically just calculated as an extra credit, but the topic itself is not an extra credit topic, which means that you could get problems like stuff like that on the next test. And if you don't do the homework, you will not be able to do that in the test. So again, the topic is not extra credit topic. But that's the last story we have in the class. Everything we've done in the class is, none of that is extra credit. Some homeworks are calculated that way, right? So the next time I meet you, we'll be on a test. The test number 4 is going to happen next Monday, and then the next Wednesday or Thursday, whichever class you have, you're going to have a test that is a final test. And then we're done, pretty much. And hopefully you're either going to graduate or going to continue to do something else. So I'm going to end up the stream here, and happy watching, and good luck on the test the next time.